Hello, today we are going to discuss about rank of a matrix. But before going to the concept of rank, we need to know the concept of submatrix. Suppose A be a M cross N matrix, then a matrix obtained by leaving some rows or columns or both of A is called a submatrix. Then a matrix obtained by leaving some rows or columns or both of A is called a submatrix of A. For example, say a matrix A is a 3 cross 3 matrix with element 2 1 0 3 2 2 and 2 5 3, and 2 2 5 3 are submatrices. Of a 4 cross 3 matrix denoted by B, which has element 2 1 0 minus 1 3 2 2 4 and 2 5 3 1. Okay, so as we can see, this is a submatrix and this is also a submatrix. Two two five three, and this is the another submatrix 2 1 0 3 2 2 2 5 3. Now we're going to discuss the concept of rank of a matrix. A number R is said to be the rank of a M cross N matrix A. Suppose we have a M cross N matrix and R is said to be the rank if every square submatrix of order R plus 1 or more is singular. Every square submatrix of order R plus 1 or more is singular, and there exists at least one square submatrix of order R which is non-singular. There exists at least one square submatrix of order R which is non-singular. Non-singular means the determinant is not equals to 0, and singular means the determinant is equals to 0. Okay, thus the rank of a matrix is the order of the highest order non-singular square submatrix. So we can say that the rank of a matrix is the order of the highest order non-singular square submatrix. Okay, so let's go further. Suppose A is a given matrix with rank 2. Then every square submatrix of order 3 or more, submatrix of order greater than 3 or more, is singular, and there exists at least one square submatrix of order 2 which is non-singular. At least one square submatrix of order 2 which is non-singular. Okay. Now, it is evident from the above definition that if A is a non-singular square matrix of order n, then its rank must be n, and consequently rank of the identity matrix of order n is also n. So we shall use the notation rank of A or R of A to denote the rank. Okay. If A is a M cross n matrix, then the rank of A is less than equals to minimum of M comma n if A is a M cross n matrix, because the largest order square submatrix of A will be of the order equal to minimum of M comma n. Okay. Now let us take an example to understand this concept properly. Example. We need to find the rank of the matrix A with element 1, 2, 3, 3, 6, 9 and 1, 2, 3. Okay. We observe that the determinant of A is equals to 0, and every square submatrix of order 2 is singular. We already know that every square submatrix of order 2 is singular. But A is a non-null matrix. A is a non-null matrix. Then we can say that rank of A is equals to 1. Okay. So that's all for today. Thank you very much.